This is -1 squared times 3. That's 3. Two negatives, -6, -1. Okay. It ends up being +6 plus 4. And you can see that that is also 13. So there's always the symmetry when you are graphing what are called quadratics. You remember that from class, teacher math? It's okay if you don't. Now, do you understand maybe my symmetry? The numbers, these two numbers are the same. The next two numbers go out to like 4 and -2. They would also be. And the reason is because that starts from the vertex. So if you can find the vertex, you get this this nice symmetry that you can take advantage of there.
Yeah.
Okay. So what I'm going to do here is make another graph here. Okay, great. So here's your new function here. Something for you to think about here. Let's say f of x equals -x squared, okay, plus 4 plus 3, okay, and I'm going to give you the table of values, just like your teacher did here. So it ends up being 2, 0, 3, and 4. So here's what you have. The value at 2. You have to do the middle value. That's generally the vertex. And I'm telling you it's the vertex. You don't have to figure that out. But then you have to pick. You either do the 2 smaller ones or the 2 larger ones, because by symmetry, the answer are going to be the same, and the 0 and the 4 answer are going to be the same. So will you give that a try for me, please?
Yeah. I got 3, 6, and 15 for 0, 1,
I'm sorry. But so for 2, you're saying for 2, you got what value?
15.
15. Okay. So this is what I'm wondering. Substituting the numbers in parentheses.
Oh yeah. Oh, I see what I did.
My guess is you're not. And order of operations tells you to square before you take the negative of it. Go ahead and retry that because that will affect this value here.
Okay. Is it 7?
Okay, so try the same thing. Now, try the same thing for the 3. Next parentheses 3 squared plus 4 times 3 plus 3. Let me know what you get there.
I got 6.
Got 6. Let's try this again. So and that's -9 plus 12 plus 3. Yes, that is 6. Now, by symmetry, what is the value of 1?
6.
It's 6. Choice. Now, I know I said earlier, either choose the 2 smaller or the 2. It is a choice. You either decide, okay, I want to put 4 in, or I want to put 0 in. If you can, you always use 0. 0 is easier because 0 squared is 0, negative 0, and 0 plus 0 is 0, lots of zeros, and then you get
Oh,
All right, so I got another, go ahead. Quick.
oh, I can't hear.
Yeah, I noticed my internet just dropped out a little bit there,
Okay.
so I apologize. That is the problem with technology sometimes. Okay, here's a new one for you to look at. F of x equals 3x squared plus 6x minus 1. Here's your table x and y. And here we go. We got -1 in the middle, -2, -3, 0 and 1. So you have to do the middle point. You have to do the middle one. Okay, no, that's no question. But then you can decide, do I want to do 0 or -2? Do I want to do 1 or -3? And I would recommend doing these ones down here. They're going to be easier. All right, so give that a try and let me know what you come up with, please.
Okay.
Let me know if you've got any values yet.
Oh, for -1, I got -4, and for -2, I got -1.
Okay, why not for -2? Did you try 0 or -2?
Oh, shoot, I did -2.
Yeah, so 0 is the better one,
Yeah,
and even though you got it right, which is great. I mean, you go for the path of least resistance, the one that you think will be less likely to cause you problems.
yeah. Sorry.
Okay, keep going. How about for 1 or -3?
For 1, I got 8.
1, 8. Let me just double check that. I got the graph. Yes, that is correct. Good. Okay, do you remember if this graph opens up or opens down and how you can decide?
It opens up because it's positive.
Yeah, it has to do with this number right here. So that tells you that it opens up. Good.
Okay.
Excellent. All right. So we're going to move on to number 10, perform the indicated operation. All right. So I guess we'll just do the one that they gave you there, and then we'll make up some ones like it. All right. So we got 4x squared minus 3x minus 6 parentheses minus parentheses 7x minus 6x squared plus 1. Okay. The only reason you have parentheses is if there's something holding it, called holding the parentheses. You almost think of docking. I don't know if you've been on the water from like boat stocking, but like you
Yeah.
need something here to like keep it. And the things that hold it are the following: a negative or a number. Okay. Now on the left here, do you see a negative where my cursor is?
No,
Do you see a number?
no.
So those parentheses are not needed. I don't even know why they put them in. They're just extra. Now, when there's a second set of parentheses, got to do the same thing. If there's a negative or a number, you use what's called the distributive property. Have you heard of that before?
Yeah.
Okay. Distributive property, it's like everyone gets it. Okay, everyone gets this negative. So a couple ways to look at it. You can look at it like you are changing the signs of everything, or you can see it as multiplying by -1. But once you apply this negative, you don't need the parenthesis anymore. -7x plus 6x squared minus 1.
Uh,
Okay.
yeah.
Now the next step is to combine like terms. And keep in mind the operator goes with it. So when I say combine like terms, okay, let me get where I can add some pens here. So 4x squared plus 6x squared. See how that plus goes with the 6x squared? Those are like terms. You probably know that, but that's an important thing to do here. So that's 10x squared. We'll do another one here. Add another pen. Go green, change the thickness. All right, so minus 3x minus 7x becomes minus 10x, or subtract 10x. And then lastly, I guess we've run out of colors here. We'll go with the red. Minus 6 minus 1 is minus 7. This is something you'll see on standardized tests, so it's really important that you have down. Let me
Yeah.
give you an example to think about, and then or a problem to try, and then we'll maybe move on here.
Yeah.
Okay, go ahead and give this one a try, and let me know your final answer.
Okay. Mm, okay, I got negative 5x squared plus 13x minus 9.
Good, very good. Okay. So I'm looking at your work, trying to decide where you went wrong. And you did this, it looks like you did this thing where you selected the right answer and then changed your mind later on.
Oh, dang it.
Let me see if we could talk about that, because that's really important to know. Yeah, I mean, I can see you selected B, which was correct, and then you went back to C. Why do you think you changed your answer?
I actually don't know.
Okay. Let me talk a little bit more about this, because it is really important here. Let's say you had something like 4 minus a minus 7, something really simple, right? When you distribute the negative, it always becomes plus whatever's inside. Okay. So this becomes 4 plus 7 because they're both negative. But let's say it's 4 minus 7. You're still distributing the negative, and it becomes 4 plus negative 7. So notice when you distribute, it's always plus, but the number could be positive or negative depending on what's inside.
Yeah.
Is that clear?
Mhm.
So the related problem to this is, like, let's say I said -2 times 3x squared minus 5x plus 6. When you distribute this -2 to everything inside here, okay, when you move this in, you see that, okay, it becomes -6x squared plus, and when it depends, like, is it -2 times -5x? Well, that's 10x plus -6 times -2 times 6 is -12, or you can write it as minus 6x squared plus 10x minus 12, but it's always plus if you want it to be, and it can be positive or negative depending on what the result is.
Yeah.
Is that okay?
Mm,
All right.
yeah.
So I see number 11, perform the indicated operation. Just trying to check your work here, see where maybe you went wrong. Plus 8c squared plus 9c. Huh. I'm not seeing where you went wrong on this one. Oh no, because you got it right. Okay, that's all right. Good enough. Okay. All right, so we're doing a lot on the distributive property here. So now I see do another problem here. And okay, so number 12. Perform the indicated operation. Perform the indicated operation. This is like a really complicated problem. You got numbers, you got negatives, you got powers, all that stuff, right? So a brief review here. What is x cubed times x to the fourth? Can you tell me that?
X cubed times it's x to the 7th.
Good. So you add the exponents when the bases are the same. Okay. Now, what is x cubed times y squared? What if the bases are different?
Then it would just be. Wouldn't you just like put x to the 3, y to the 2?
Yes, it's the same. Okay. Now, with this given problem right here, I'm gonna actually grab it snip one more time because we did a little dialogue on that. To just kind of reframe the problem here. So there's what will happen over time is you'll eventually just be able to do this, but until then, there's this intermediate step where you actually show the multiplication. Okay, there's the distributing of the first one. Remember I talked about it's always plus in between? Because you just keep the terms as is, and then you treat the the negative always goes with it. Treat it as negative 6x. Okay, that's why there's a plus in between. So now you've got to like look at this, mess of numbers, but it's number times number, x times x, y times y. So that would be negative 20. X cubed times x to the fourth, that's x to the 7th. There's really an exponent of 1 there, so it becomes y cubed like that. Plus, we don't know whether it's positive or negative. Negative 4 times negative 6 is positive 24. X cubed times x is x to the fourth. There's nothing to multiply but y by, so it just stays the same.
Oh, so you wouldn't not put so it would just be like, oh, I thought it was like multiplying y by 0.
Well, it really is y to the 0. But what is 1 plus 0?
Oh, I guess it's 1.
It's
Yeah.
1, so it still works. So if you need to, you can put a y to the 0 in. That's okay. That's allowed. Now, what I'm seeing on your test is that you wrote this. Like you had this perfect, but then you had the idea that you could combine these. And the only way you can combine them if they have the same exponents exactly.
Okay. So when you're adding, they have to be the same exponent.
Everything's got to be the same. It's got to be an x to the 7th. Okay. So just like we did in the previous problem up here, you could only combine things that are the same power. 4x squared, x squared, 6x squared, minus 3x, minus 7x. And I think you know this. I think just because there was 2 letters, maybe that was more of an issue, or you just got excited, like, oh, it's minus 20 plus 24. Okay, it's 4. I've been there. You think, okay, I got the right answer. These multiple choice are tough, but you can do it. So this is it. This is your answer.
Okay.
Trying to think of a good analogy, but I'm not really coming up with one. But you can only combine terms if they're exactly the same.
Yeah.
Exactly. That'd be 100% the same. Okay. So let's have you try one. like this. Let's go minus 3x squared y to the fourth times negative 2x plus 3x squared y, like that. Okay, so go ahead and try that and let me know what you come up with.
I got 6x cubed y to the 4 minus 9x to the 4 y to the 5th.
Very good. Very good. Okay. Now here's something to think about. I'm gonna write something here. Let me write this. Let's go x plus y plus 1. Okay. Are these like terms in here?
No.
Okay. So let's just pick something to multiply on the outside by. Let's pick 3. This becomes 3x plus 3y plus 3. Are there any like terms here?
Like terms, no.
Nope. Now let's change it. Let's say it's we put an x out there. What does this become?
It becomes x squared plus xy plus 1x.
Okay. Do you see any like terms?
No.
No. Well, maybe if we do a y, we'll get some like terms. This becomes xy plus y squared plus y. Any like terms there?
No.
Let's try with xy. This becomes x squared y plus xy squared plus xy. Do you see any like terms?
No.
Okay, so here's what we can summarize. We can summarize and say that if there's no like terms inside parentheses, there's no like terms outside the parentheses,
Oh. Yeah, I get
right?
it. Yeah.
Right, like nothing we can multiply by can make these like terms. Okay, so when you had this problem, one of the things you probably didn't hear this because most teachers wouldn't tell you this, but if you can't combine them now, you can't combine them later. So notice though that that's different. That's different than, let's look at this problem up here that we did. This problem right here that we did. Remember we distributed the negative, and then I said to combine like terms.
Yeah.
What's different about this problem? How many sets of parentheses do you see?
2.
2. So it's possible when you have 2 that you can combine stuff. But if you notice inside parentheses, if you can't combine it here, when you negate it, you're not going to be able to combine it there. You have to have something else to combine it with. But within the parentheses, once you distribute, there's nothing to combine.
Okay.
All right, good job on that. Let's see what's next here. So I'm also noticing this pattern of like you start out really strong and then kind of you hit the midway point and things go bad. Is that consistent with your other tests where you're kind of doing okay for a while and then you hit a rough patch?
Yeah.
Darn. Okay. That's good stuff for me to know. I can talk to mom about and let her know, some of these patterns I'm seeing. Okay. Here we go. New question. So not exactly the easiest thing to start with here, but you've got all the right things. You've got the foil denoted. Okay. You're like, hey, I'm going to take 3a and multiply by 5a. That's 15a squared. 3a times minus 7b minus 21ab. And then minus 2b times 5a minus 10ab minus 2b times minus 7b, that's 14 squared. Okay. So the lone mistake that I see is you forgot to square right here at the end on your answer for number 14. Sorry, this is number 14. Should maybe snip that in. Okay. So this is a good start. It's a good start. 15a squared minus 31ab plus 14b squared. Okay. Then the next step is to distribute in. Now, a couple things here, just like we were talking about, if there's no like terms here, there won't be any like terms when we're done, when we
Yeah.
multiply. Okay,
Mhm.
so that's kind of important. Second thing is if you make a mistake here, it doesn't matter what you do next. It will be wrong.
Oh.
So it's like you got to get the FOIL right. Tough FOIL, but that's the way they've got here. Okay, so when we distribute in, it's 60a to the power of 3. 4 times 15 is 60. A times a squared is a cubed. Then it's minus 124 a squared b plus 4 times 14, 56 ab squared, like that.
Yeah.
Now there's a couple of things that I can show you. I do a test prep class, and one of the things that we could do is actually look at answers like this and figure out, well, why is this one, how can we distinguish between them? And notice it really comes down to the kind of the middle terms, maybe the end term. Okay, so that's just something to think about here, maybe for the future. So let me have you try some FOIL again here. Let me have you try this one. 2u minus 3v, 3u minus 4v. Would you FOIL that for me, please, and let me know what you come up with?
Yeah. Oh, those are V.
Yes, and they do choose letters that kind of look the same sometimes to make it more challenging,
Oh, yeah.
deceptive.
Oh, okay, that makes more sense. So it would be 6u squared.
Good.
And then it would be minus 8uv. And it would be negative or minus 9 UV. Plus 12v squared.
Really good. So what I'm noticing, and I think this is really important for you, is you have to treat that negative like it's going with the one on the right. That will really help. You have to look at it as minus 3v or minus 4v. Okay,
Yeah.
really good. So are there any like terms? Anything you can combine down here?
Yeah, you can combine the negative 8 UV and the negative 9 UV to be negative 17 UV.
Good. And you bring the last one down. Now, this is the correct way to work a problem like number 14 on your test. Now I'm gonna add in, let's say I'm gonna add in, let's go for U on the outside. So now there's really a for U in each of these steps, but you ignore it until you're ready to work it. Okay, so go ahead and finish this one off for me, please. Go ahead and multiply out.
Okay.
Let me know what you come up with.
It would be 24 U cubed minus
So think of 4 times 17 as times 17 times 2. Figure out that number and then multiply by 2 again. Double and then double. Speed it up for you.
Okay. So 3468. So 68 U squared V.
Good.
And then that would be plus 48 V squared U.
Try to keep them in alphabetical order.
Oh yeah.
Which I know, like sometimes you go through your ABCs and do. That just helps them with grading.
Yeah.
Now I'm looking at 15. You got -1, and I don't understand why. Like it's correct as is. Do you have any idea why you lost a point or what was taken away? Maybe is a better way of saying it on 15.
No.
So on the sheet, yeah, sometimes I'm sort of at a loss. I'm like, what's going on? On your thing you turned in. I mean, this is what I'm seeing. Correct. 36x squared, 60xy plus 25y squared. Maybe your instructor wanted you to use special products and not FOIL.
Maybe.
Is that possible? Is he the type of teacher that would say, if you don't do it the way that I want you to do, that you're going to get deducted a point?
Yeah, but he didn't tell us we had to use special product though.
That was my next comment to you, is it does not say, please, use special products to calculate this. So you
Yeah.
probably go back to your teacher and get another point on this. If you say to him, hey, look, I foiled it. I've got the correct answer. I'm not sure why I lost a point.
Yeah.
That's up to you. Also talk to mom and maybe give her that feedback as well. It's really good for me to see this because it helps me to know what kind of stuff your teacher is emphasizing.
Yeah.
All right, number 16. Ooh, okay, there's a lot here. This type of problem. There's a lot to do to even just start it, and we have to talk about negative exponents. Okay, so we're gonna do this in pieces here. What is the exponent of 2 that's not written?
0.
Nope.
1.
Because 2 to the 0 would be 1. Yes, there's a 1 there. And for now, it's like you almost need to write that. So top left here, you see this is -2 times -3, -2 times 1. So the numerator becomes 2 to the -2 power, x to the -6 power. Is that okay?
Yeah.
Over 3x to the -5 power. Now, the property for negative exponents is that really x is x divided by 1 to the -n. You can think of this x as being x over 1. And then the negative exponent allows you to flip it. So when you flip it, it ends up being 1 to the n over x to the n. And that's why it becomes 1 over x to the n. And that's because 1 to the n is always 1. So most teachers just show, or they'll just show you this, but I want you to see how it actually works. It's really x is a fraction. You flip it, that changes the exponent. 1 to the n, x to the n, 1 to the n is always 1. That's how you get this here.
Yeah.
So the other thing is that some students, they recognize, well, if it's negative, I just flip. Like this becomes, I just move things. So like x to the 6th goes down here and x to the 5th goes there. Same thing is true of the numbers. 3 is on the bottom, 2 squared goes on the bottom. That's kind of one way to look at this. The other way, I don't know if you like that. The other way is to kind of look at the 2 to the minus 2, 1 over 3, x to the minus 6, 1 over x to the minus. So I kind of break them all up. And then this 2 to the minus 2 becomes 1 over 2 squared times 1 over 3 times 1 over x to the minus 6, sorry, positive 6 times x to the 5th over 1. That's another way to do it. How do you see it? What makes sense to you?
I think the bottom one.
One on the left here, bottom left?
Yeah.
Okay, that's fine. So you whatever you do, you have to come up with, okay, I got tops and then I got bottoms. So 2 squared is 4, 4 times 3 is 12, 12x to the 6th, but we're not done. There's more, and there's also a 1. There's always a 1 in the numerator or denominator if needed. When you have the same base and you're dividing, you subtract the exponents. So notice here, it becomes x to the 5th, x to the 6th is x to the 5 minus 6. And sometimes there's a question about where this actually goes because it's x to the negative 1. When you subtract, it always stays in the numerator. So it'd be 1 x to the minus 1 over 12. And then you have to again kind of reposition it so that it's 1 over x like that. The x to the minus 1 becomes 1 over x, becomes 1 over 12x.
Yeah.
Okay, so there's like a lot encoded in that question. So if you didn't understand it at first, I mean, we didn't do any talk of negative exponents. It's tough. It's really tough.
Yeah.
All right, so now all of that we just did, and you know, I write big, I want to explain it to you, but all of that we just did is just this part on the left. That part on the left becomes 1 over 12x plus 2 over 6x squared. Why can I just drop the parentheses here? It's related to something we did earlier. Is there anything holding it? Anything in front?
No.
No, so they're not needed. Okay, what is the requirement to add fractions?
Um.
Like,
Uh.
can you add 1/3 plus 1/4?
No. Well,
No.
yeah, but you have to
What do you have to do to the bottoms here?
multiply negative, or I mean 1/3 by 4/4, and then the other one by 3/3.
Okay, so what you're doing, what the reason for that is you get a common denominator.
Yeah.
So the same thing applies here. You need a common denominator to be able to plot these. Okay, so this is, I mean, this is a little bit beyond your course, but the common denominator on the left will be 12x squared, 12x squared. It's called the least common multiple of these things.
Yeah.
All right, so the next thing here is you ask yourself, what do you multiply 12x by to get 12x squared? X,
Yeah, X.
x and x, because the x times the x gets you to 12x squared. So in the numerator, it becomes x.
Yeah.
What about in the denominator?
The denominator,
I'm sorry, the other fraction. We want 12x squared from 6x squared. What do we multiply the top and bottom by?
You multiply the top and bottom by 2.
By 2. So that's 4 over 12x squared. Now you can add the tops and keep the bottom.
Yeah.
Okay, so we're gonna do some negative exponent stuff, and we're gonna add, and then we're gonna do problems where you have to make a common denominator, but we're not gonna do them all together because that will be confusing. So let me give you a problem to think about here. Why don't you just tell me what 3x squared to the minus 2 power is over 4x to the minus 10. Why don't you simplify that for me?
Oh, okay. It would be
Take your time, work it out slowly, deal with the negative exponents, ask questions.
all right. So you would do the negative exponent to the parentheses first, right?
That's right, like 3 to the minus 2, x to the minus 4.
Okay.
That's your first hint if you need it.
Okay. And then you would have to flip it, right? So that
When you
the
say flip, be careful here. What are you flipping?
the x to the negative 10 to the top.
Okay, that's true. That's true.
And
How about the x to the minus 4?
you move that one to the bottom.
Okay, and like you just said, when you flip it, you gotta be careful with that word, but that's fine. It becomes a positive exponent.
Yeah.
Okay, what about this 3 to the minus 2? Where does it go?
The bottom.
And what does it look like on the bottom?
It would look like 9x to the 4th.
Look like 9,
Oh,
3
sorry,
squared,
9.
right? What about this
Yeah.
4? What happens to it?
It just stays there.
Yes. And what number is not written but is still on the top if needed?
1.
1. Good. Okay, go ahead and keep going. You're almost there.
1 times 10. 1 x to the 10 over 63 x to the 4th. So that would be x to the 6 over 36.
Good. Real good. Okay, we got just limited time left here. Let's try one more of these. Let's go x to the negative 2 cubed over 3x to the minus 5. Go ahead and
Okay.
simplify that one, please.
X to the negative 6 over 3x to the negative 5. That would be 1x to the 5 over 3x to the 6. Then that would be 1 over 3x.
Very good.
Cool.
All right. Now, we did not get through everything on your test today in terms of your corrections.